Another thing, as you know, with fixed effects, sort of an ANOVA approach, is you want to be sure that your model assumptions are met, and you often do that by checking residual plots. Well, in sorts of models we're looking at now, then the residuals are not independent. We're assuming that the repeated measures are correlated. So what's actually being assumed is that the residuals have got a multivariate normal distribution, which we can sort of write like that. So this is multivariate normal, the residuals are assumed to have means of 0, and they're correlated with this R matrix. So how do we go about checking that? It would be simple if we just had 2 repeated measurements. We could do a plot of bivariate distribution and see if it was sort of had a nice shape, but really if you've got several, that's not going to be possible to plot it in several dimensions. But fortunately we can scale the residuals, and so this is actually the residuals in matrix format. So they would need to be pre-multiplied by the inverse of this C matrix, and this C matrix can be considered as the square root of the overall residual correlation matrix, that matrix up there, which has got all the covariance patterns in. So once you've done that, you've scaled the residuals, then they can be treated as independent and they can be checked using residual plots. Yeah, if you came to the mixed models presentation, I said the random effects need to be checked as well. But here, generally, we don't fit any random effects. We're just modelling covariance patterns, so that's what it's just for residuals that need to be checked. And if we do that for this study, we get some quite nice plots. That looks really nice, and that's a normal plot, which should be a straight line. There's a bit of deviation up here, but it's not really anything to worry about, and the histogram of the residuals is quite symmetrical. So I was quite happy that this was a satisfactory model to analyse that data. That was an example of how I might have gone about analysing normal data that's considered normal and choosing a covariance pattern and some of the effects that might have gone in the model.